In this video, we will learn how to derive the Marshallian demand function and Hickian demand function, and how to, derive the indirect utility functions and the expenditure functions. Okay, so I will be explaining all the stuff here, so bear with this video. So in the Marshallian demand function, what happens if I take a utility function? Consumer wants to maximize his utility, that is U is equal to X times Y. That means consumer wants to maximize his utility subject to the budget constraint. Let us say we have price of X times units of good X plus price of Y times units of good Y should be equal to the income of the consumer. Okay, so with the given level of income, consumer wants to achieve highest satisfaction, and when we solve it, we get the Marshallian demand function. And what about the Hickian demand function? In this case, the consumer wants to minimize the cost or expenditure. So consumer wants to minimize the expenditure. Let us say E. What will be the expenditure? That will be price of good X times units of good X plus price of Y times units of good Y. So with the given prices, consumer wants to minimize his expenditure such that he wants to achieve a certain level of utility. And let us suppose we have the utility function X times Y is equal to U. Okay, let's say U naught. With so here what happens, consumer wants to reach a certain level of utility, and to get the certain level of utility, he wants to minimize the expenditure. So this is consumer duality problem. Either consumer wants to maximize utility or minimize expenditure. In this case, what happens with the given level of income, consumer wants to get the highest possible utility or satisfaction. So if I draw a simple graph to make sense here, so let me draw a simple graph to explain the two things. So let us say we have X on the horizontal axis and good Y on the vertical axis. So what happens here? Consumer is faced with a certain budget. Okay, let us say this is the budget line of the consumer. With this budget line, what does the consumer try to do? He wants to get the highest possible utility. That is, let us say this is indifference curve 1, then we have indifference curve 2. Okay, so with the given budget, consumer wants to reach to the highest possible indifference curve to maximize the satisfaction. Okay, and what happens in case of the Hickian demand or expenditure minimization problem? What happens? So we are saying we have the same two goods X and Y. Okay, in this case, utility is held constant in the Marshallian demand function, or in case of maximization problem, consumer's income is held constant. So utility is held constant. That means we have this indifference curve. Okay, so we have this indifference curve, or we have U naught here. Utility is fixed. So with the given, so the consumer wants to reach a certain level of utility, and to get this level of utility, he wants to minimize the expenditure. So let us say this is the one expenditure function, then we have another expenditure function. Okay, so what happens here? We are being given the fixed level of utility. Consumer wants to minimize the expenditure. In this case, we are given the budget line, and consumer wants to get highest utility. Okay, so how do we solve them? So there are two methods. Either we use the tangency condition or Lagrangian method. Okay, for the sake of simplicity, let's take the tangency condition. So what will be the optimal condition in the case of utility maximization problem? That will be consumer gets the utility maximization when he equates the marginal rate of substitution between two goods and set it equal to the budget, that is the ratio of the prices, price of X upon price of Y. Here also same thing happens, marginal rate of, because what is the optimal point or utility maximizing, rather the optimal point in both the cases when the slope of the indifference curve and the slope of the budget line are equal, and in this case also when the slope of the utility function or the fixed level of utility, this indifference curve, and the slope of this expenditure, price of X upon price of Y, they are equal. we get the optimal bundle of good x and y. So here we have also price of x upon price of y. This condition should be held in both the cases. So MRS is nothing, it is the slope of the, this is slope of indifference curve, and px upon py is slope of budget line. Okay. Now we know how to calculate the marginal rate of substitution. What is MRS? So let me write it here, then I will wrap. MRS is simply the ratio of the marginal utility of good x upon marginal utility of good y. So MUX is simply the change in the utility due to the consumption of good x. MUY is the change in the utility due to the consumption of good y. That is the partial derivative of utility function with respect to good x, and marginal utility of good y means the partial derivative of utility function with respect to good y. Okay, so if I take the partial with respect to good x, I will get y in the numerator. If I take the partial derivative with respect to y, y will get the derivative of y will be 1, so we are left with x. Okay, so MRS in the both cases we have y upon x, and here we have also y upon x. Or let me write for both the cases what happens, what we do. In the both cases what we do, we equate for both cases M or S, or whether we have the utility maximization or cost minimization. We equate the marginal rate of substitution between good x and y with price of x, the ratio of the prices of good x and y. Okay, in both the cases we get y upon x is equal to price of x upon price of y. Okay, or y will be equal to, y is equal to price of x upon price of y. So let me be price of y times x. Okay, for both the conditions we get this result when we equate margin, MRS with the ratio of the prices. So I don't need to write it here, and also I don't need to write here. Okay, so let me rub, because I have to consider other things also. So let me rather repeat it here. So consumer faces a dual choice. Either he wants to maximize utility subject to the given level of income, or he wants to minimize the cost subject to the given level of utility. Okay, so in this case the consumer's endeavor will to maximize the utility, which is equal to x times y, subject to price of x times units of good x plus price of good y times units of good y should be equal to income. In this case he wants to minimize the expenditure, so expenditure will be equal to the prices of good x times their costs correspondingly, and in this case he wants to reach a fixed level of utility, that is x times y should be equal to u naught. In both the cases what happens, with a given budget, consumer wants to reach highest possible satisfaction. So budget line is given, we reach highest indifference curve. In this case indifference curve is given and we want to reach the lowest possible ISO cost line. Okay, for both the cases we will get the optimality condition requires we equate marginal rate of substitution between two goods with the ratio of the prices. MRS is simply the ratio of the marginal utility of good x and y, and px upon py, rather here we have y. This denotes the slope of the budget line. In this case we call the expenditure line, in this case we call it budget line. Okay, so now to find out the Marshallian demand function, what we do, we also call this uncompensated demand function. Okay, so what we do, we plug the value of y is equal to px upon py into x into the budget line. Okay, we plug the value of y here. So when we plug here, what will we get? We get price of x times units of good x plus price of y times units of good y. Here we have price of x upon price of y times x, and it should be equal to the income of the consumer. Doing some basic cancellation, so this py gets cancelled. So we have price of x times x, price of x times x. So we have the same terms, we can add them. So we have twice px into x is equal to m, or x will be equal to m upon 2px. Okay, this is the Marshallian demand function for good X. Marshallian demand is a function of income and prices. Okay, so that means demand for good X is a function of income and price. Okay, now what will we do? We plug X is equal to this stuff into this function, so we will get X is equal to, rather Y will be equal to, that means Marshallian demand function for good Y will be equal to M upon 2 dy. Okay, so you can calculate it by yourself also. Plug this value in this equation, you get this demand function. Okay, this was about the Marshallian demand. Now how to find out the Hickian demand function? So same thing, what we do, we plug the value of Y this time in this function, okay, the constraint function. So we have X times the value of Y is price of X upon price of Y times X should be equal to the U0 as pixel level of utility that consumer is trying to get. So we have X times X is X square, okay, is equal to, plug this here, so we get U0 price of Y upon price of X, or X will be equal to under root of U0 price of X upon, rather we have price of Y upon price of X. So this is our Hickian demand function. These are the Marshallian demand functions. Okay, so this is the Hickian demand function. So it is a function of utility and prices. Okay, we call it the compensated demand function. Likewise, if we want to find out the Hickian demand function for good Y, we plug this value into this function. Okay, and let me show it here. Okay, don't get confused. So Y subscript H means Hickian demand function will be equal to, so we have price of X upon price of Y times the value of X is this. Oh, okay, can I write it like this? U0 raised power 1 upon 2, price of Y raised power 1 upon 2, price of X raised power 1 upon 2 to solve this, X. I have just expanded it. So YH will be equal to, so what will we do? Plug this X here, or transpose these here, so we get price of Y. If I transpose it here, raised power 1 upon 2 minus, or can we do one thing here? So we get price of Y, so here we have X upon Y. If I do one thing, let us plug this X here to the numerator. Okay, so we get price of X times price of X raised power minus 1 upon 2, and similarly plug, we have price of Y, transpose it here, so exponent sign will change, it becomes negative 1 upon 2, and we have U0 1 upon 2. So 1 minus 1 upon 2, we will get here price of X raised power 1 upon 2 divided by price of Y raised power 1 upon 2. Because bases are same, we can subtract the exponent. Then we have U raised power 1 upon 2. That is, so if I write it in this fashion, so we will get U0 price of X upon price of Y. Okay, so this is the Hickian demand function for, so this is Y subscript H. This is the Hickian demand function for good Y here. Okay. Having said that, when we maximize the utility with the given budget line, we got the Marshallian demand functions. When we minimize the utility, expenditure subject to this given level of utility, we got the Hickian demand function. Marshallian demand function is a function of income and price. Here you can see Hickian demand is a function of utility and the prices. Now we can also find out the indirect utility functions in case of Marshallian demand function. What we do? So indirect utility function, how do we find out? We plug these values of the demand functions into the utility function here. That is, we will get the utility function, which will be a function of price of good X, price of good Y, and income, and I can show it here. So it will be equal to, so XM is in place of x we write this stuff, in place of y we write this stuff. So we will get m upon 2px times m upon 2py. So we will get m square divided by 4 px py. This is our indirect utility function. Okay. In the same way, what we do, we need to find out the expenditure function in case of Hickian demand. What will we do? So to find out the expenditure function, we plug the value of x and y into the expenditure function. So what will be the expenditure function? So expenditure will be a function of price of good x, price of good y, holding utility constant, that is the function of utility. So we plug these values, or okay, so let me see if I have the space here. So we have this function, that is u naught, rather we have price of x, so we have price of x times x is under root u naught price of y upon price of x, plus then we have price of y times y. So the value of y is this, again u naught. So let me rub this out. Okay, so we have u naught price of x, price of y. Solving it, we will get, so doing some simplification, so this under root will go here, so it will become price of x raised power 1 upon 2 u naught 1 upon 2 price of y 1 upon 2, plus here we will also get price of y 1 upon 2 u naught 1 upon 2 price of x 1 upon 2. Okay, so what we have done, we have transposed this here, so we will get here under root of price of x, price of y, u naught, plus here we also got under root of price of x, price of y, and u naught. That means our expenditure function, expenditure will be a function of price of good x, price of good y, and utility, which will be equal to, so we have same terms, it becomes 2 times price of x times price of good y times utility. This will be our expenditure function. Okay, so this is how do we solve how to get the Marshallian demand function, Hickian demand function, indirect utility function, and expenditure function. I hope I make myself clear and you find out these videos helpful. Please subscribe this channel, share it with your friends. That is the only motivation for me to make more useful stuff for you people. Okay, see you next video.